Hi, how's everyone going? About to start. Okay, this is continuous integration. It's been marked advanced, but it is really an introduction to CI. So I'll try to be clear about sort of what's in it in case you're expecting something different. I'm Boris. I'm a developer at Previous Next. And I've been a Drupal user for about 6 years, about 4 professionally. And might just get a quick gauge on who's in the room. Who here is actually is pretty sure they know what CI is about or have built so you're not supposed to be here, okay? That's fine. But it might be useful anyway. So I'm going to take a little bit of a different approach with this talk. I'm not going to do like a long demo where I just hit buttons on Jenkins or anything like that. It's not very tool focused. I'm going to try and get into some of the motivations for actually doing continuous integration and try to get to some of the reasons why we don't do it in Drupal projects for the most part. Of those people who built CI setups, are you doing this on Drupal projects? Could you put your hand up if you are? Yeah, okay, interesting. So that's probably about a third of the room. All right. Okay. So I think about half of you don't really know what CI is about, so we'll cover that. And particularly how it might apply to Drupal projects. So this is a bit of a forward-looking topic to me because one of the prerequisites for continuous integration is good testing, and I think that's sort of a bit of a weak spot in Drupal, and it's kind of a motivation for a lot of the Drupal 8 core work. So I think it's a good topic to start thinking about some of these practices. And I don't know if anyone was in the Agile project management talk this morning, but it was kind of mentioned that Drupal projects tend to be a bit behind the ball with a bit behind the times with a lot of Agile practices. And all the Agile talks I see at DrupalCons, for the most part, tend to be project management focused, and not so much, some of the classic extreme programming practices of which CI is one, or test-driven development. I mean, I'd be very doubtful that many Drupal projects are doing much proper test-driven development, and there's good technical reasons for that. It's kind of difficult, but that's sort of the framing. So what we'll actually go through is some of the motivations for CI, where what problems we're trying to solve. It is not a tool-focused talk, so it's really about getting the idea that we're trying to improve quality and doing that by not letting bugs get released, basically. So we'll go through some of the basics and definitions and some ways, some kind of first steps that I've found to kind of get started that will make later on tying things together with a continuous integration server a lot smoother if you kind of start on the right foot. So and a lot of it's about clean lines with your practices. So deciding where your tests go and how they run, and then what happens at deploy time, and trying to get some real consistency around that. So, and of course, we will cover continuous integration servers because that's where it all comes together. So I'm not going to demo Jenkins. I'm not going to try to tell you which tools to use or give you sort of like one perfect one-size-fits-all. I'm really hoping that you'll come away with this understanding the goals and knowing how to kind of build your own toolkit, like a framework to think about some of the things that continuous integration kind of brings up. So I think it's an interesting topic as like a sort of a catalyst for thinking about a lot of agile processes. So even stuff down to the way you're dealing with user stories, and then how you're going to actually, like I said, implement things like test-driven development, or how you're reviewing your architecture. It all sort of gets touched on. So we won't be talking about writing tests. There's a good talk tomorrow, particularly Drupal focused on writing tests. You should go to that. And that's sort of the overview. Okay, so we're talking about build phase quality is the motivation here. So problems with defects. So not pre-build, but really these parts here where we design, develop, and test locally, then probably deploy to a test server. So you should be familiar with this process. And then there'll be a review, and then we fix bugs. And that's when we start to get sometimes some annoying regressions, and we fix more bugs, and it gets expensive, and they can kind of loop. And it all comes down to defects in the build, mostly. Well, that's what we can deal with CI. Other agile processes might deal with leaks in requirements or handling that, but this is engineering focused, so right there. Okay, so just a quick review of Software Engineering 101. We don't want to release defects because it's just cheaper to fix them now than later, basically. So it turns out that we want to. This is some of the motivation behind agile engineering practices. Is we want feedback so that we can fix them early, and you see the cost increases not only when the defect is earlier, but also when it's detected later, so earlier stage. So a defect in requirements detected in a production release is most costly. So we're trying to improve this cost down at the front here. So part of the problem is we do a lot of parallel development, and kind of developers go off on their own and work on their own solutions, and you know that's good, but it can lead to problems with too much work in progress, and obviously it has to all get integrated at some point. So maybe some of you have experienced sort of an integration hell moment of your own, where you know you're working on a team and somebody is working on a feature, and then they go away for 3 weeks, 4 weeks, and then when they try to actually bring it back in, there's problems. So that's one motivation. So we want to integrate small parts, but you know obviously there's overhead with that. Integration can be sort of boring, constantly syncing from a common branch, a mainline, and then running tests again, and then going over and over. So we'd like to do it, but we want to kind of make it a good process, something that we want to do all the time. So remove that friction. So that's sort of some of the things we're dealing with here, because and that's where some of the processes and tools come in. So we're going to try and automate the integration task and try to make it not so wasteful in terms of time, but do it often. So if it feels good, do it. Integrating it can be painful, and integrating small changes reveals problems earlier. That solves the problem we're trying to solve, and regularly produces feedback quicker than integrating at larger granularity. So that's why these people came up with the idea to integrate all the time, which can sound crazy if you've never seen it before. But it can be done with tools and with a bit of discipline and a bit of practice and a bit of careful thought about what you're actually doing. So when we say continuous integration, for those that aren't unaware of what we're actually talking about, any change to the project, and that can be some configuration or generally source code in the application, would, whenever it's done in a common main line, that would trigger some sort of automated integration task. That's what we're sort of aiming for. So the goal is, again, to not release defects into production. So we do that by keeping a careful eye on code quality, the quality of the project at every moment. So we also, going back to those ladybugs, want to keep them in check and not let them sort of go off on their own and build incompatible solutions. In a Drupal example, maybe use a module stack that is against what the team has chosen. So maybe you're building a project with a context module stack that ties in with Omega and does a lot of stuff like that, and they go and install panels to do some layouts when you've been building a bunch of stuff with Delta module or something. So that's one sort of motivation is to try to keep that under wraps. So that's one type of quality is sort of site building architecture. But it's mainly transparency. I mean, we want to know what state the code base is in, everything from code styles to of course test running, because we want to fix defects early. So that's the main goal. So it's a bit of a different mindset. You might be used to having a development server that you're kind of happy to be at relatively unstable states at all times, and you kind of, I'll fix it later, I'll fix it closer to launch, or I'll fix it at the end of an iteration. So this kind of makes you take a step back and makes you agree as a team. No, we're gonna actually maintain stability in this branch. So wherever code gets integrated, it has to be clean. So the starting point, any developer can in theory come on, download the source code, trigger a build. We'll go over that in a sec, and get going, and not worry about there's some broken state they have to deal with and whatnot. They should always have a clean point they can start from. So, and there's some other workflow processes that this touches on around how you handle defects. You have to decide as a team: are we going to, how many defects are we going to deal with? How long are we going to let the build, the state of the code go bad, and do we stop everything? That might be a good option. Just everyone stop and fix it if it's like gone a day and the code's the red light's gone, then you might want to fix it. But it gives you sort of a framework to make those decisions as a team. But obviously the goal is to keep it fixed. So it's not about just sort of installing a robot on a server that automatically deploys necessarily. It's a big topic, and I think it's something that we'll think about more as Drupal 8 starts to reveal itself, and we're writing more unit testable code in particular. And I think it's something that's very applicable to distribution development and using Drupal as a product platform, which Therese mentioned this morning. So if you're thinking of a startup or something like that, then this is the sort of process you probably want to keep in your mind when you're setting up your workflows. Okay, so part of it is thinking very clearly about when you're performing your various activities and putting a bit of structure in place. So it can be a bit prescriptive workflow-wise, but there's flexibility in terms of actual implementation. So you should be building up these processes from the bottom up, and but being careful about what you do. And we'll go through some examples, but so some clear definitions of what I mean by build. We kind of throw these words around in CI and don't really think too much about what it means. And I think it helps to be a bit more concrete. So build is, the confusion is because we use PHP, a lot of times we'll sort of deploy with version control or something like that. And the source code will be sort of considered the deployable item. But I think you'll notice that if you're using Sass or again, this is something that's probably going to come up more with Drupal 8. There are things that you always have to do. Sometimes you do it in the deploy, but something you have to do to the code base to actually get it executable or runnable. And so it's a bit it's a bit abstract and a bit wafty, but it's some result of so you start with your source code, and then you do a build, and then you'll have something at the end, and that can be some process code with Sass run on it. Maybe you run tests, you've got test output, and then the executable part is ready to deploy to any environment, preferably. So testing, kind of enough said, but we will test as part of a build process, and then have some test results, and that will be considered, that's an artifact of the build, and it's about trackability. So when we do automate this stuff with the robots and get Jenkins to actually start, or whatever you're using to start running these processes, these builds, then you'll be able to use this data in much more useful ways, the test outputs. So and then the deploy is the easy part. It will change from environment to environment sometimes, but you'll have some little extra steps. But for the most part, you just once the build is complete, you're just copying the file somewhere, so they can be executed, maybe with some configuration. Okay. So there are sort of some core rules that you're supposed to go by. It's sort of textbook continuous integration, but I think it's useful to sort of quickly go over them. When we say integrate, we mean check into mainline. So that might be a little bit confusing if you're coming you've only known Git, or I imagine pretty much everyone here would be using Git to manage their projects. So what does that mean, mainline? Well, it's not as obvious, but it's any nominal branch that we've picked as our stable branch. So we don't have a separate develop branch. You develop in a topic branch or a feature branch, experimental branch, and then when you want to integrate, you do it would be the push. The integration would be the push, but you can integrate locally before you push. So, and remember, the goal is to keep that mainline stable. So we'll be testing as a real human element to this that's kind of forgotten. It's not about offloading the tests to the test bot, and kind of not really testing it properly and waiting for it to fail and come back. It's really about extra gates to quality. So we're really serious about quality. We're going to test against any new code now before we push it off to GitHub or the central repository or whatever, and we're going to catch that before. So the continuous integration server later on, that will be another gate that the goal is to never have that go bad. So Now it should be fast. That's another important thing. And test everything that can break. So from a Drupal perspective, just to tie that into the first point, we want to run all our tests locally because we don't want the build to break. But that doesn't mean that we're sitting there running the whole simple test suite for core every time we do a change local or every time we want to merge into mainline. So we're only concerned with things that can break. We may not even run all those tests on. We probably wouldn't even run them on a continuous integration server. I mean, that could be a real later stage, and we'll get into testing and how you can kind of divide up the different tests into different stages. But so building and testing should be very fast, and again, it's because we don't want to make more work. I mean, this is a hardcore view of quality, but you have to recognize that we're lazy, and as soon as testing becomes hard, and I think this is obvious for Drupal, testing Drupal is hard, and so we don't do it as much. So if you're gonna start down this route, you don't want to just sort of install a CI server or make some process that makes it difficult. I think developers have to be able to run tests locally fast, do builds locally fast. So this is tricky stuff. All right. So build speed and test speed all have to go quickly. Okay, so I think it's important to kind of highlight. This is again probably looking a bit more forward to Drupal 8 when we will have more unit testable code. You can write unit testable code now for Drupal 7 for your custom modules. I'm not sure it's done much. Does anyone here write proper unit tests, or as opposed to just simple tests? No? You've done a couple? Yeah. So it's the domain is quite limited at the moment. If you're writing anything that maybe interacts with an API, you might want to look into it and use. In that case, you would not use simple test. You would use something like PHP unit. Mainly because you probably want something like mock objects or some way to run. Just to be clear, when we're talking unit testing, we're talking about essentially testing a function, a method, a class. So some block of specific code, how the code actually behaves in terms of what functions it gets called, what it returns, the kind of internal APIs, not the end-to-end functionality. If you've seen simple tests, they're more about creating nodes and users and how functionality interacts. That's functional tests. So there's a big difference between the time that these things can take, because testing one function's return or one class's methods, how they behave, versus how a bunch of modules behave that needs a Drupal install to get run. This is a huge difference. So you don't necessarily want your developers to have to run every unit test every time they make a change. They may want to run unit tests only when they make every change, and then when they go to merge, run custom simple tests. These are the sort of strategies you'll want to come up with, and it's all about removing the friction and making testing not fun, but not something you try to avoid. Smoke tests are probably pretty useful if you're wanting to test configuration. Going back to, we want to test things that can break. So I think it's not really useful to sort of write simple tests that are only going to test whether or not your wiring is working, your Solar server is talking to your application. But you still want to test that stuff because things can go wrong. Configuration can kind of get awry sometimes. You want to detect bugs in your build and deploy process. So you can just do simple things like have a shell script that you add a bunch of commands. They can do curl commands and check output and just check pages up and just real simple stuff. And you could run them on every integration build externally. Would sort of make sense, or pick the right point for that. And then can, it goes all the way down to automated acceptance tests, which I've actually noticed a lot more activity in Drupal around that sort of stuff, a lot more excitement. But they generally would take a really long time to run because you're testing end-to-end user functionality, either through a browser or a headless browser. And there's a lot, you can read up on behavior-driven development from an acceptance test user perspective if you're interested in that, but it's not really in the scope of CI so much. But you would, if you ran them, you would run them again, would not make your development team run the whole suite every time they wanted to merge. So, okay, so yeah, we want to split them up and be careful about which tests run when. Okay. So it might not be that obvious that this is related to continuous integration, but it actually is, because you want to have as few differences from environment to environment as you can. So anything that you're doing, any process, say the SAS example, or if you're compiling SAS manually and you're not checking the CSS in, you want to have all those tools, all those things that you're automating as kind of as consistent as possible, and it's just easy to maintain. That you can actually write builds that have very little difference when you have to run them in different places, and you know where those differences are, and they're in very specific spots. So all tests should be runnable locally. Even the functional tests, it's just that doesn't mean you have to run them every time. So these are the sort of policies that you kind of coming up with. And again, the goal is to have a sort of a local development environment where developers don't get caught if they come onto a new project. They don't have to necessarily sync from a particular database, or if they do, then it's well defined. They don't have to think about, is it using SAS or not? Do I have to manage that myself and kind of dig in? It's all automated and consistent, and that's where build tools come in. So it sounds like a bit of work or a bit of a change, but I think that if your application, if your site can't exist without like a particular database, I mean, that's a bad smell, right? So this is just sort of taking that a bit further. It should be essentially installable, and someone should be able to pick up the source code and just start working. They shouldn't have all these external dependencies. So that's sort of one of the reasons for dividing, being careful about automating a build and keeping every step that's involved and every requirement in check. So these are just some okay. I'll skip through these a little bit quicker. This is once you've got an automated build and you kind of get going. These are the sort of things that we're aiming to do. So sort of best practices to maintain that quality. So not checking on a broken build, running tests locally before merging. We covered that. Keep the mainline build stable. Know how to manage instability. So it's all about having these policies, and then having probably a system around who's responsible for fixing things that break. So this is an interesting one is dealing with architectural reviews, because these things are hard to test and hard to get a red light to go off. I've seen some tools, some PHP static analysis tools that might help, but it's a tricky one. So you'll need to consider that as well, because that's technical debt, which is another form of defect. If your system is difficult to extend and maintain, but it may be difficult to test. So. And slow tests, yeah, a big no-no because it will make people stop writing tests. Code style is sort of one of the simplest things you can automate. And again, it's about sort of just picking up a sense, being a bit more hardcore about quality, picking up a sense of when, you know, maybe someone was rushing some work or something like that. It can be a good, if your team's really buzzing along, and sometimes I've seen tests where they not so concerned with strict code quality fails, getting everything to fail all the time, but being a bit tricky with analyzing the changes in the defect numbers, so that they'll see like a variation, a statistical variation, and there'll be a sign that something needs looking at. But these are easy to do for Drupal, obviously, because it's a static analysis, so you don't have to write the tests. But you know, it only gets you so far. So the automated build is sort of what you want to start with. I think it's a better place to start even than you know, some auto deploy, which I think is where some people start when they're trying to implement CI. They'll you know, do automated deploys or code style checks. But before you get to that point, I think thinking about your build process, going from source code to something that can be deployed or run locally, and having that consistent is kind of overlooked. So I might just quickly switch over just to give you some idea of what, if you haven't seen a build tool used before. There's a bunch of them out there. You could use shell scripts. Preferably you want something that's going to make it easy to get status codes when things go wrong, so that again, when you automate it later, you'll get something going. So let's see, we've got just a simple project repository. So it's not you know, actually for this one, it's the use case is install profile development. So we want to develop an install profile, maybe push it to Drupal.org. So it's going to have very specific repository requirements. It has to use these kind of specially named make files for the Drupal org, so that when you download it, it gives you the zip of the whole distro. So that's the source. But the rest of the project management stuff, the build scripts, we check everything in a version control. So configuration and build scripts to get us from source to something that could be deployed or run locally. So this is Fing. It just lets you define tasks that you're going to perform, and generally you want to run have the default be something that would be the one that gets automated and kind of a pre-deploy step. But locally, it can be configurable. So I'll give you a quick example. I'll go to another folder and clone in an empty. So a copy of the same repo. So this repo has the install profile is a submodule in this case. You know, that's just an option because for this case it's thinking about a Drupal.org submission, so that's a decision that's been made. Some stuff to help set up a database user, and then the build tasks. So if I just ren Fing, it would run the default build task. But well, I might do that now, actually. I have another one though that will do the default build, install Drupal, and then actually kick up a PHP server, so you can actually sort of just run it. So rather than do them in steps, So this is sort of the long build. This is the sort of thing. You still configure your builds. You have the same process and try to share, remove duplication in your build scripts. So that ran. And what did that give me? This gave me a doc route that I can actually in-build, and you can see there's Drupal, and I can point a web server to that and start developing in it. But that default build is actually the production build. So I've got this configuration, and probably my steps for developers would be download the source, either copy this or run it, and then set development to true. I'm in a different folder. Set development to true, and that will give me some slightly different. I want to do different things for local builds, so this is sort of where you can share that build code, and have it sort of be reusable, and probably have a template or two actually. There is a build XML file for Thing that tries to cover all the bases in terms of whole directory, make files, no make files, that sort of stuff. I think it's probably best to start from scratch, but use the same process of trying to reuse the code. So if I rerun Thing with the development mode, instead of doing that whole download of everything from scratch and starting from nothing, which you might do on a production system to make sure that's all running, it's development focused, so it just rebuilds the install profile. So that would be, adding a module to a make file and quickly kicking that off. So it's the sort of things you can do with automated builds. And obviously in there, I would do SAS file compilation, things like that. Okay. So tests are part of the build. They're the other artifact other than the deployable object that you're generally going to have. And so for continuous integration, there is a standard, this JUnit standard that you should be aware of. Once you start digging into this, that will be well supported by different continuous integration servers. So I think this build had some tests already done. There's the test folder, and you can see there's a bunch of XML files. So that's also in the build. So we've got if we ran this on a production machine, we'd have code coverage reports, test output, and then of course the deployable artifact being the application production ready. Change log removed, everything, maybe. Okay. Static analysis, yep, same. Code coverage, code style checks. These should all be checked and considered a part of every single build. So every time we're going to merge in, we want to develop, generate all this stuff and make sure it's up to scratch. So deploying, I think it's, there's some things you have to do from environment to environment where you'll still want to keep the same project repository, but maybe there'll be some sort of production difference. I mean, there might be particular requirements for a hosting provider about sort of where code has to go. So again, we're really getting away from sort of a common model of just running git pull to deploy. I mean, it's very, very, very far from that. But the advantage is that we can do things like use a tool like Capistrano just for deployment. So it does this one job very well. It moves files from one spot to another, maintains versions, can trigger backups, and then it does basically atomic switching by changing a symlink, swinging a symlink around. So that's a lot more preferable than just doing a git pull and having database, even if it's only for a moment, you'll have database and code out of sync. I mean, there is a possibility. I mean, it may seem like really nitpicking, but there is a possibility that your schema and your execution, and it may be non-destructive. It may just be someone clicks on a page and it doesn't work, and then when they go back and the update functions have run, it's complete. But we have good tools for this stuff. You set it up once, and they're very reliable. So that's kind of a different view, defining your build first and your build tasks, and try to keep that stuff a bit drier and cleaner. And the advantage being that once you go to actually automate this stuff with a continuous integration tool, then it really sort of falls out quite easily. So the CI server doesn't do anything really magical or special. It's just glue. Sits between some version control repository with that sort of code that I showed, and the build tool or build tools or scripts that get run to create your artifacts. So the advantage being that it can also collect information about the build state, so all those test outputs, and graph them, build times, performance testing. So you're kind of off on the right foot if you kind of start from the bottom up, and rather than the other way around. Okay. So Jenkins is a CI tool that you'll most likely use, or I know some people have probably already installed and are using it. It has a lot of advantages. It's very powerful. It's free, but I think it is probably worth looking at some other tools. I think sometimes we get a bit lazy with this stuff and kind of just go to the common one. So there's some interesting ones. ThoughtWorks have one called Go, which has a lot more of a focus on the gates and visualization of the build. Because again, we're sort of tracking build quality and only promoting builds that pass our gate quality tests. First a local gate, and then the tests that run on the CI server, and so on. So we know that when we pick that build and we move it up, it's exactly the quality that we need. So Travis CI is sort of an interesting one. I haven't had much internet here today. In fact, no internet, but I'll quickly see if I can. This is like probably the easiest one to set up. If you just want to sort of have a play, you've been playing with the automated build, and you want to start doing it for real. You can put a single YAML file into your project repository. You do need to use GitHub. It's not going to be usable at the moment for client work. It's at the moment it's an open source tool. I think they have a commercial tool in the works using the same stuff, but it's you can get up and going in about 5 minutes if you have an automated build already working. So you just well, I'll show you the YAML file. It's pretty. Okay, so you can declare a couple of different environments, PHP 5.3 or 5.4, and some other ones, I think, and set some database stuff. Do some environment setup. So the main one for me is installing some pair dependencies, thing of course, and related, and then I just run my same thing build. So this is exactly the same build script that I developed for the local, set up my local environment, which even I have a different database config for this one, but actually that could be easily refactored. This was just the first attempt, but the install script is exactly the same, and it all goes pretty smooth. Anytime now, the way Travis works, it's tied into GitHub, so you put in your GitHub account, you can see all your repositories, and then it just picks it up. So anytime I do a commit, it will actually there's the build output. That's just the thing output. And then if it errors and it comes up red, you get an email just like you would with your own Jenkins. And then you could do some other stuff. Obviously, auto deploying from here would probably not work. But if you've got a good build process where there's very little difference and you're using the same build scripts, then you could use this as a check, and then I think there's an API, and you could kind of wire something together. It is for open source development though, again. So I don't know if I can just, probably got about 15 minutes. I might just go a couple more minutes and just show you this is of course the classic CI demo as you change the documentation. So of course I would have, if I was doing CI properly, I would have ran the build locally and make sure all my tests pass, etc. But and I'll just let that trigger off. No, I can't. Haven't been getting internet today. Oh. Should run another build. Let that run. Okay. I'll go back to it at the end. So that's sort of the long, broad how to get started on continuous integration. These are some books that I found sort of useful, particularly actually the continuous delivery one, which isn't about continuous integration, but touches on a lot of the same sort of quality philosophies. This Drupal thing build file is probably not, I wouldn't use it, like just use it for a project, but it's good if you wanted to see some examples. You can cherry pick some stuff out of there. I think it needs some rewriting in places, but it's definitely a good start. I'm putting up a sort of a real simple like starter template that will cover different layouts, but with some a bit more refactoring in there. And I think that's about it. I'll check the build, see if it went green. Oh, there we go. It's run. Yellow means it's running. So it's this is a full clean slate production build. So it doesn't even have Drush on there. I have to install that. But that's it. I think I'm ready for questions. If anyone has any, or if you want to talk about something that touches. I know this is a lot of different topics. If you want to ask any questions about specific tools or pain points that you've had understanding or implementing. Yep.
Were you saying that Travis CI tool only works with GitHub?
Yes. There's a .com page I think that they've got up. So they've obviously got a commercial service running at the moment, but at the moment it's free for open source projects. So definitely if you had other PHP projects that were open source, I would highly recommend looking into it because it's just so quick to get started. But again, you can, I think Thing is pretty transmittable skill tool. Like it's reusable in different environments, different situations. Works great with Jenkins, and the output kind of comes in just sort of automatically. There's a plugin, of course. Yeah.
Would you tend to sync config from a staging server or something throughout the process?
Right. Yeah. Well, I would. So the question was, would I sync? You mean database sync? Yep. Like say production data to staging. I would consider that a deploy step to staging, so probably. Or it could be a special case for your. This is why deploys are kind of funny. It's so specific to sort of what you got and how much data you have. If you've got a really big database in production, you might not be doing that so often. You have some other process in place, maybe a daily dump, and then you're syncing from that. So there are some environment specifics. I'd like to keep that more probably in the deploy configuration because it's specific to an environment.
So a lot of the things that you do with Drupal, like you do it through the configuration, like views and things.
Yeah.
How do you test those?
Simple test if it's functionality. There's a talk tomorrow on simple test. Okay, so you're doing some site building and you want to have some automated testing around that.
Yeah.
I would look into simple test as a first step, and maybe later you could look into some acceptance testing stuff with the hat and Mink. But I think simple test is probably your first go-to, and you can include the test in the feature module and have it run. So I didn't really kind of get to that, but there's that output, that XML output was just simple test output. So generally for your build, that you'd have all those simple tests running on every build, like for just your modules, not for core and contrib. Nope. Okay. Thank you.